Today, we're jumping straight into the science of learning and remembering.
Yep, specifically looking at the material you shared with us.
Right. You clearly want to get knowledge effectively, and we've looked at your sources, research papers, notes on study habits,
Mm-hmm.
and we're trying to pull out the most powerful, evidence-backed ways for you to learn faster, more thoroughly, without getting, overwhelmed.
Exactly. We're really trying to get under the hood of the cognitive processes involved. And, well, there was one study in your collection that really jumped out.
Oh, yeah. Which one?
It was about surgical residents learning to suture arteries. Fascinating stuff.
Okay.
So you had two groups, same resources, same total study time, but one group just learned differently.
What happened?
Well, that group performed significantly better a month later, just because of how they learned. It really shows how much the right strategy matters.
Wow. Okay. That's pretty compelling. A small change makes a big difference in something like surgery skills. So what was their secret? And what else can we take from your sources? That's our mission here, to give you actionable strategies backed by science that you can use right away.
Whether it's for work, personal interests, whatever you're learning.
Exactly. So we'll look at how memory works, first the foundation, then we'll dig into active testing, mixing things up, and timing.
Let's start with the brain basics, based on some of the neuroscience in your reading.
Okay. So how does new information actually get in and, well, stick?
So when you first encounter something new, maybe like details of a complex system for your engineering work, as your notes mentioned,
Right.
it lands in the hippocampus. Think of that as sort of a temporary holding bay.
Okay, a holding area.
Yeah. And as you review it, maybe reread those articles or look over notes, the pathways in the hippocampus for that info get activated again and again.
And that repetition, that's key, isn't it?
Yeah.
It's not just about understanding it right then.
Precisely. It signals to the brain, hey, this might be important.
The attention.
Exactly. Every time those neurons fire together, the connections, the synapses, they get stronger.
Yeah.
That's memory stabilization, basically.
Okay.
And over time, that knowledge, say, the engine design you were studying, it gets kind of transferred, moved to a more permanent storage place.
The neocortex, right. That came up in the reading.
That's the one. The neocortex for long-term storage.
Now, this transfer process, it's not like just dragging a file on a computer, is it? The sources suggested it's more involved.
Definitely not drag and drop. The exact process is still being researched, but the consensus in your materials is that it happens between study sessions.
Ah, okay. In the downtime.
Yes, and crucially during sleep. That seems really important.
Sleep. Right.
The brain is actively consolidating then. It's linking the new stuff, like that engine design, with what you already know, maybe physics principles or material science you already understand.
So it's building connections, making a richer picture.
Exactly. Weaving it into your existing knowledge web.
Makes sense. Your brain wants to connect the dots. And once it's stored long-term, it's not just locked away, right? Pulling it back up does something.
That's right. Every time you recall a long-term memory, you reactivate those pathways. And what's really interesting, and it's in those articles you shared on memory reconsolidation, is that recalling it makes the memory a bit flexible again, open to updates, strengthening, integrating new related info.
Okay, so recalling reinforces it and keeps it current.
Yes, and that leads us perfectly into the first big technique from your sources, the power of testing.
Okay, testing. So like flashcards, quizzes, trying to explain something out loud without notes.
Exactly. Anything that forces you to pull the information out of your own head. Active retrieval.
Why is that so much better than just, say, rereading my notes or highlighting passages, which I admit I do a lot?
Well, the core reason, and this is all over the cognitive psych papers you sent, is that testing forces retrieval. Rereading just involves recognition.
Recognition.
Yeah, you see it on the page and think, oh yeah, I know that. But that can be misleading. It creates a false sense of competence, sometimes called the fluency illusion.
Oh, I know exactly what you mean. You read it, it feels familiar, you think you've got it.
Right.
But then someone asks you about it or you try to actually use it and blank.
Precisely. Because passive methods don't make your brain work hard to access the info. Testing is like, well, a mental workout for that specific information.
Okay, a workout. Makes sense.
And here's a really interesting bit from the research you found. Getting answers wrong during self-testing. That can actually boost long-term learning.
Really. Making mistakes helps. That feels wrong. Like, shouldn't I avoid mistakes?
It feels counterintuitive, yeah. But the research is pretty consistent. When you struggle to recall something and maybe get it wrong, your brain is actively searching. Then, when you see the correct answer, The contrast makes that correct info stand out more. It gets encoded more deeply.
So the struggle and the correction kind of flags it as important.
Sort of, yeah. The brain learns from the error. It's like it says, okay, that was wrong, this is right. Got it. So don't be afraid of mistakes during practice. They're actually useful.
Okay, that's a relief, actually.
Yeah.
Reframes mistakes as part of the process. So active testing is number one. What's the second big idea from the materials?
The second one, which popped up in several of the educational psych articles you shared, is interleaving.
Interleaving. What's that?
It basically means mixing things up. So instead of studying one single topic for a whole session, like blocking your practice,
Right.
you switch between different, maybe related subjects or types of problems within that same session.
So if I'm studying, I don't know, different coding functions, I wouldn't just do loops for an hour. I'd mix in loops, then maybe conditional statements, then arrays.
Exactly that. And the research you gathered suggests this mixing leads to better long-term retention and, crucially, better ability to apply the knowledge later compared to just focusing on one thing at a time.
That definitely feels counterintuitive. Wouldn't focusing intensely on loops until I really get them be more efficient?
You'd think so, but the leading idea, based on those studies, is that interleaving forces more mental effort, similar to testing.
How so?
Well, when you switch topics, say from loops to arrays, you have to mentally retrieve the rules and context for arrays. Then when you switch back to loops later, you have to retrieve that information again.
So it's more retrieval practice built in just by switching.
That seems to be a big part of it. That constant retrieval strengthens the memory for each topic you're switching between.
Okay.
But there's another benefit too. By mixing related concepts, you get better at telling them apart. You start to see the subtle differences and understand when to use loops versus when to use something else.
That makes a lot of sense, actually. Especially for things like math or coding, where knowing which tool to use is half the battle. You see how they relate and differ.
Exactly. It helps build that discrimination skill, relevant for a lot of the technical stuff in your sources.
Okay, got it. So testing forces retrieval, interleaving forces retrieval, and helps you tell things apart. What's the third key technique? The final piece.
The final piece, and this was emphasized everywhere in your readings on memory, is timing, specifically spaced repetition.
Spaced repetition. So spreading out my study or review sessions over time.
Yes. Instead of cramming reviews close together, you strategically space them out over increasing intervals, days, weeks.
Okay. This one sounds simple, but yeah, I've definitely crammed before deadlines. It feels like it works in the moment.
Yeah.
Why is spacing better long term?
Because spacing gives your brain the time it needs for that consolidation process we talked about earlier.
Right, the transferring to long-term storage, linking things up.
Exactly. That happens offline, between sessions, especially during rest and sleep. Cramming just floods the system.
Too much, too fast, with no time to process properly.
Pretty much. Your brain doesn't get the chance to properly encode and integrate the information for lasting retention.
So those all-nighters might get me through the next day's meeting or presentation.
Maybe for immediate recall, yeah.
But the information isn't likely to stick around afterwards.
That's what the research strongly suggests. And this takes us right back to that surgical resident study in your materials.
Ah, yes. The suturing.
Remember, both groups had the same total practice time,
Right.
but the group that spread their training over 4 weeks space practice, they were significantly better surgeons a month later than the group that did all their training in one single day.
Wow. Same time, just distributed differently led to much better skills.
Yeah.
That's really powerful evidence for spacing.
It really is. It highlights that it's not just about how much you study, but when and how you revisit the material.
So these three things, testing, interleaving,
Yeah.
spacing, they're not just random tips.
Not at all. They work because they align with how our brains are actually wired to learn and remember. They tap into those core processes: encoding, consolidation, retrieval.
Leveraging the brain's natural systems, basically, according to all the science you looked into.
Exactly. Optimize how you feed information in and how you practice pulling it out.
Okay, so let's quickly recap from your sources. To learn more effectively, test yourself. Actively force that retrieval.
Yep, embrace the struggle, even the mistakes in practice.
Then mix up your study topics, interleave, to deepen understanding and see connections and differences.
Right, avoids shallow learning and builds flexibility.
And finally, space out your review sessions. Give your brain the time it needs to consolidate that knowledge for the long term. Ditch the cramming.
Precisely. Allow for that crucial offline processing.
And these aren't just for school, are they? Your notes suggested wider application.
Absolutely not just for school. These apply to learning anything new, technical skills for work, a musical instrument, a language, understanding complex reports, anything.
Universal learning principles.
Pretty much.
Okay. So, thinking about all this, here's something for you, our listener, to consider. How could you use one of these right now?
Yeah, maybe pick one. Could you quiz yourself on something you read today?
Or maybe deliberately switch between two different projects or topics you're working on this afternoon, instead of focusing solely on one. See what happens.
And think about the connections. What insights might pop up when you mix different areas of knowledge you're exploring? Using an idea from one field to spark something in another.
It's all about working with your brain's natural learning style, based on this research, to really make knowledge stick and be useful.